Good morning, all of you. Okay, so I'm sharing my screen. Yeah, so we are into the topic industrial Internet of Things. Okay, so we have seen all these things. I just told you about industrial Internet of Things is an application of IoT in industries to modify the various in existing into the industrial internet of things. Because why here two things has to be mentioned, because internet of things is different. IIoT, just you may forget about the one I, and you may be thinking of IoT is both the things are same, but there is some difference because the terms are looking similar, so there, but there is a difference, so we can understand. So the 3 points which are explaining about the IoT is a different. So here coming to the industrial internet of things is an application of IoT in industries. This is in industries like smart homes, smart cities. That is just a different application regarding the cities and homes, and the smart parking. So different things. And coming to this industrial IoT here, it is like to modify the various existing industrial systems. Like what are the industrial systems are there? To that, additionally, we are adding the Internet of Things, like Internet of Things devices. We are adding IoT devices here. We are adding, and IIoT links the automation system with enterprise planning and product lifecycle. So it mainly focuses on the enterprise level at the industries. So this is all about the IoT, in IIoT. So this is just taking the features from the two things like Internet of Things and Industry 4.0. Okay, so so that is how it is making the the smart factory. So this is how in Internet of Things, it is completely at the consumer level, and industrial Internet of Things, it is at the enterprise level, like it is like having the product life cycle. So I mean planning. So this all things also it will discuss. But here coming to this, it will be at the consumer level. So those are just evolution. What are the things? So this all things we have seen. So we were discussing. So these all things we discussed. Like all we have seen the differences between these two things, and we have seen the differences between IoT and IIoT. M2M, sorry, M2M here. If you see in this diagram, M2M mainly focuses from devices to complete other applications of the system, but this IoT completely focusing on the system integration and other applications like network connectivity, service enablement, and application and data. So these things like some these are the key application areas of IIoT: manufacturing industry, healthcare service industry, transportation, logistics, mining, firefighting. So these are all just the applications of IIoT. So here, like transportation and logistics and mining to prevent accidents inside the mines, their RFID and Wi-Fi and other wireless technologies are used. Provides early warnings of any disaster, monitors air quality, and detects the presence of poisonous gases inside the mines, oxygen level inside the mines. So sometimes we have seen. So actually we were at this slide, I stopped. So examples of IIoT or this things, yeah, I think finished this one. So we see it's okay. Unmanned aerial vehicles, UAVs to inspect oil pipelines. These are just examples of IoT, monitoring food safety and minimizing workers' exposure to noise, chemicals, and the other hazardous gases. An unmanned marine vehicle which can collect data up to a year without fuel or crew. So those are just examples of industry things. What are the things are happening? So that is just the example. And connected ecosystems in IIoT scenario. So traditional supply chains in industries are linear in nature. So to shift the business focus from products to outcomes, new ecosystem should be followed. Digital ecosystems progress at much faster rate than the physical industries, hence it quickly adapt the changes in the external environments. So integration of digital and human workforce, guys, you don't think this, what are these things and what we are like, it's the scene, these all things like a industry, so many things will be there, right? So many things will be there, and each and everything how this IoT can help, and what are the things if you are going with the IoT at the industrial level, what happens. So those things we are just seeing. Okay, mainly the things you have to write for the exam, industrial internet of things, that you have to write, like you should give some difference between the IoT and IIoT, and those things which I said you, the previous, some of the applications of it, and the industry revolution about. So these all slides are very important. In the starting, the initial slides are there, right? In the exam answer, you cannot write all these things. Okay. So, but the things here you can mention, like so these diagrams are important, like so here you are seeing the screen, right? Internet of things, IIoT, actually what it is, it shows. So that main difference between those things, and so these diagrams are very important. If you draw, because just like there's more than an answer I can say. So these the diagrams, and you can uh, give explanation, so it really making sense, like what is IIoT, we can easily understand. So these things are very important, I think. Yeah, because you even you study, I don't think so that you can remember everything. So what you can do is the important things, when you read the answer you will know what are the important points, right? So those things you remember and write the answer in effective way. Okay, so if you have any doubts, like when you're studying and all, you can ask me. That's not an issue. So we are just seeing complete industry level what is happening, that's it. Okay, so how many things you can remember, how many things you feel important, you just take that and you write. Like this applications of IIoT we should write, this is the important thing, and some of the differences are between those two things. And so these all things, like some things are important, so those things you have to mention there. Yeah, I think this is just easy, like, at fire mining places, what are the things you can be avoided if you are going with these things. So those things we can easily mention. So integration of digital and human workforce in IIoT machines become more intelligent, hence the automated task can be done in the industries at lower cost and higher quality level. Humans will work with the machines. The outcome will be higher overall productivity. IIoT will reform and redefine the skills of the workers and creation of new jobs. The creation of new composite industries such as precision agriculture, digital healthcare systems, and digital mines will lead to development of new job opportunities because of the IIoT. Like we are using the new technologies and everything, so there is a chance of new job opportunity. Highly automated machines will require less number of unskilled workers, but will require skilled experts with the digital and analytical skills. Reformation of robots, like the existing robots we can reform the IIoT environment. Like robots are featured with three capabilities like sensing, thinking, and acting. They will be reformed with the ability to carry out repetitive tasks. Robots will be more intelligent, but work will under the supervision of human beings. Their availability will increase. So robots, they can observe. The real time monitoring of these things is possible. Robots will be reprogrammable to perform some new tasks. They have the capability to learn faster. So challenges, there are challenges in IIoT. So what are the challenges? There are primary challenges. Identification of objects or things, first challenge, and next manage huge amounts of data, because we are changing the everything, like the existing system we are modifying it to new, with the sensors and actuators and different IoT devices we are adding to those things. So those things continuous monitoring we need. So because for the real time monitoring to make it possible, make the things smarter, even you are not there at the industry. So we are just getting the, no need to be at the physical plant, but here at the virtual plant, like all the data you're getting through the IoT devices, right? So that we can say a virtual plant which is existing at the cloud, you can use the data and everything. So that means you are getting the huge amount of data. So managing it is again one more difficult task. So integrate existing infrastructure is into a new IIoT infrastructure, enabling data storage. So these are all things to enable the data storage for such amount of data is difficult task again. So safety challenges in IIoT, worker health and safety. Okay, there has to be focus on these kind of things, worker health and safety. In medical, in pharma, so sometimes the workers may, involve in the some different chemicals they have to work and such kind of things. Some medicines may affect, and the mines, there is a chance of some things like in the steel industry. So different places are there. That time, the safety is very important. So workers health and safety, one challenge where it has to be focused. And next, regulatory compliance. Regulatory compliance in the sense the rules and everything, or in the industries. And next, environmental protection. Next, optimized operations. So these all things has to be taken care at the safety challenges in IIoT. And next, hazards. So these all things are related to handling, storing, or using hazardous substances, oxygen deficiency, particulates, and radiation and physiological stress. Something. These are the different challenges, and we see some of again standardization. So standardization plays an important role in the development of the system. Goal to improve the interoperability of the different systems, applications, and allow the products or services to perform better. Standardization here, the problems related to the standardization are, so just we are talking the word, but we see what are the problems comes here. Standardization here, interoperability, semantic interoperability, security and privacy, and radio access level. These are the some semantics. As I told you, semantic interoperability here, in the sense, some sensor, it will send the data in different temperature is equal to 26.C, like some Celsius. Likewise, it is sending some, say, other sensor, it will send the data like temp is equal to, or T is equal to. So it will send different things. It will give the data different things. So all different things, other device, how it can understand, like human means we can understand, but the different semantics, the different things, different vendors are manufacturing the things, right? So it will be different. So understanding and all semantic data semantics, so such kind of things is a difficult thing. And next, privacy and the security issues. Here the two most important concerns related to IIoT are information security and the data privacy protection. The devices or things can be tracked, monitored, and connected, so there are chances of attack on the personal or private data. Next, privacy and security issues. Examples: healthcare industry, food industry. In the medical, data of a patient must be tampered or altered by any person in the middle. So it may be the chance of attack on the data of patients. And next, food industry, the deterioration of any food item being sent to the company must be kept confidential, as it will affect the reputation of the company. And next, through the IIoT provides new opportunities, but few factories may cause hindrance in the path to success, which are lack of vision and leadership. These are the risks associated with the IIoT in manufacturing: lack of understanding of values among management employees, costly sensors, inadequate infrastructure. So these are the reasons. So next, meet some of the challenges here. Improvement in sensor technologies. So sensor improvement, like the sensor performance has to be taken care. Miniaturization means in the sense sensors has to be small. If the devices are small, they consume low power, and so we can use the things like in any technology we can add those things. If the sensor is itself very, because this consumes the power all the time, so it has to be small. So that is the one consideration. Next, the performance has to be more, and next, cost and energy consumption. So these all things, cost of the device and energy consumptions, these all things are to be taken care in the sensor. Next thing, manufacturers use software capabilities to improve operational efficiency through predictive maintenance, savings on scheduled repairs, reduced maintenance cost, and reduced number of breakdowns. So next case study are TTech Software. This tech particularizes in software which improves industrial facilities efficiency and improves the productivity. And this is just a one software we are just talking about it. RT-Tech, that is the, and energy management solution. It is an energy management solution which leads to reduction in the plant's highest variable cost. RT-Tech automates the process of mapping and managing energy consumptions. This is the like industrials, we can use one such software which is developed for the IIoT at the industries, that just it improves the, this is one case study, it improves the industrial facilities efficiency and it improves the productivity, and it gives the energy management solution as well. Okay, so next we see products developed. So M2M communication, for that intelligent radio modem, it has been developed, and our IRM 1500 and ACE 1000. So these are the different variations in that, and simple M2M connectivity, data transmissions. These things has been possible with this. And next, these devices provide a easy maintenance and installation, so they can be connected to IP and non-IP serial devices to extend the capability to monitor and communicate with other technologies. And here I told you that in industries we use even M2M, because so here this sometimes through the gateway we can provide IP based network and the non IP based network. Okay, so when the non IP based network, so that time M2M communication we can do. Okay, so here we see in the, when the M2M communication, in the sense that device to device communication is possible when sometimes the network is not there. Okay, so even the data is possible for us when we are using this M2M. So control IO link master gateway. So this is one of the gateway. So products which are developed. So it can be easily integrated into the industrial network with existing and new installation. It supports Ethernet and Profinet and Modbus, TCP, some different things. Benefits of IIoT. So these are just some of the benefits: improved connectivity among devices, improved efficiency, upgraded scalability, reduces operation time, and remote diagnosis, and cost effective. So some of the recent research trends in IIoT are to improve the communication among the different things or objects, like in the industries, and next to develop energy efficient techniques so as to reduce power consumption by the sensors, and to develop context aware IoT middleware for better understanding of the sensor data. To create this context aware IoT, in the sense it mainly and distributed control of assembly line and automated monitoring. control and maintenance. So these all things are possible at the industries if we are going with the IIoT. So we just see last topic in our syllabus. So that is smart grid. This is the last topic here. As you can see here, my screen, in my screen you can see here, these are the topics which already we discussed, like case studies and cloud computing. So next we discussed the connected vehicles and industrial IoT. Just now we discussed. Next we discussed the sensor cloud, smart cities, smart homes. So these are the topics which are in the fifth module. So last topic we have it here, smart grid. So we discuss about this and we can finish our portion. But I don't think so now itself I can finish it. We see what happens. So smart grid. Smart grid in the sense here, just we are talking about the energy, okay, power, electricity we are talking, okay. So how we can make it smarter, okay. So those things here we are talking. Just before we were talking connected vehicles and smart homes, smart cities. Now we are talking smart grid. Before we spoke about the IIoT. So different things, to make it smart cities, smart homes, and all the concepts to come. So everywhere everywhere we can implement this IoT. Everywhere we can use this IoT. So how it can make the things smarter. So those all things we are going to talk just in the smart grid concept. Okay, so we see what are the things. So okay, so how many slides I have? So okay guys, so here we see the introduction, advancement of a traditional electrical grid. This smart grid is the advancement of traditional electrical grid. Traditional electrical grid, what actually happens, what is the concept, we see first. Energy generation is done in centralized power plants. Energy distribution is one direction from the power plant to the homes or industries. Okay, so this is actually generation is done from the centralized power plants, and then from centralized power plants the energy distribution is one direction from the power plant to the homes or industries. Okay, monitoring and restoration of grid is done manually. Monitoring and any things like any somewhere some some like something trees fall down or anything, some this kind of incidents happen, so manually the person has to go and they have to do, right? So what actually is happening, we see unidirectional communication. Okay, so next coming to the smart grid, what is happening here? Achieve high reliability in power systems, a cyber physical system equipped with sustainable models of energy production and distribution and the usage. So here in traditional electrical grid we are consuming electricity, right? So that is generated by some station and carried and transmitted through different transmission devices, right? So generally to speak, I'm saying different transmission devices and transmission lines. So either to homes or offices or industries. So in terms of Internet of Things, here what is happening in the smart grid concept, I told you. So anything to make it possible, here we are using ICT technologies, ICT information communication technologies. Okay, so here not only the sensors and actuators, we have some advanced advanced information technologies from the electrical sciences as well we are using. So so in terms of Internet of Things, the advanced information and the communication technologies to make everything smart, here we are using ICT, and one of the important components is electricity distribution to homes and offices. That has to be made smart, right? So that is where smart grid comes into picture. I think you are understanding what actually we are talking. Here the traditional electrical grid being made smart, okay, being made smart through the use of ICT tools and different advanced information and communication tools being used to make the traditional electrical grid as a smart grid. Okay, So smart grid mainly it concerns energy generation. It typically done in a centralized manner at different power plants. This generation can be two types. The energy generation can be two types, right? So as we know, we can get the energy from renewable and non-renewable, like with solar, wind. So these are the things comes under the renewable, like reusable things. But when you are going to the non-renewable things, means there is coal and the water. If you take those things are like we cannot reuse, like there is a chance of we are end up with the sources, right? So that those things are the non-renewable. Okay, so these things we already know those things, right? Renewable, non-renewable, we studied, right? So what happens here, this energy that is generated at different power plants through the centralized mechanisms, traditionally in one direction from the power plant. As we are talking, those things are just the energy which is generated, that is coming to the homes or offices or industries, right? So this particular flow of electricity is monitored. If something goes wrong, the restoration of the grid is also done manually, right? So we have unidirectional communication. The energy flows unidirectionally. Also, the communication is also unidirectional from the source to the end consumers. Okay, so we see in the smart grid there is a divergence from the traditional concept. That means it uses the information and the communication technologies to achieve higher reliability in power systems. So we see here what is happening. We understood some things about this. So if we go more into this smart grid, we can understand. Okay, so many slides are there. So if we discuss those things, we can understand what is smart grid. Smart grid is conceptualized as a planned and nationwide network that uses information technology to deliver electricity efficiently, reliably and securely. Okay, so here in the traditional grid, what is happening we know. So as because we are using the electricity at homes and offices, so we are seeing what is actually happening, what can be done if anything goes wrong. So those things we know. But coming to the smart grid, it's a so you should know that, like, what is it, what actually it is differentiating. So here this is conceptualized as a planned nationwide network that uses the information technology. Here it is using information technology to deliver electricity efficiently. And smart grid also can be named as a electricity with a brain, the energy internet, the electronet, we can call. So according to the definition given by NIST, the smart grid is modernized grid that enables bidirectional flows of energy and uses two-way communication and control capabilities that lead to an array of new functionalities applications. So here what happens in here, I'm saying here reliable in the sense if something goes wrong, how things can be taken care of. Okay, and if something, it may be some substation goes down, overall distribution goes down. So then even if it is goes down, the smart grid is going to still function without any interruption. That is not possible with the traditional electrical grid here. Okay, so smart grid basically also tries to address this particular problem that securely. So here we are talking securely, right? So securely this electricity can be transmitted to the actual consumers. Okay, so these all things can be taken care smart. So here, yeah, I told you in the smart grid, as we are using computer based methodologies and some different technologies, we are using information technology, communication technology, etc. So it becomes very interesting. So like it becomes very smart. So because we are using all these things. So some people prefer to call smart as, so some people are prefer to call this as a smart grid, and some people prefer to call it as a electricity with a brain, and some people prefer to call it as the energy internet or electronet. Okay, so here we have according to NIST. So the definition we have here, right, as I read before. So according to this, what is the meaning? So I just want to conceptualize this once. Like according to NIST definition, the overall thing is service electricity. Okay, overall thing is a service. Okay, electricity is a service here. It means the electricity is a service. So offering electricity to the n number of consumers are getting this service in their homes and their offices and in the industries and workshops, so on, right? But what makes the electricity smart or smarter or interesting? So is that because two-way communication here it is using, so before in the traditional grid what is happening, that the electricity is just passing, that's it. Okay, so but here it is using the two-way communication, not only from the source, not only from the source towards like source to the end users, and in the other direction what is happening, it is even having the information. Okay, it is having the information regarding uh, the electricity flow. Okay, so benefits of so next thing we see, we not need to discuss that now. So we see the things. Okay, so benefits of smart grid. If you see benefits associated with the smart grid include, so here we have the information regarding the network flow, like electricity flow. Okay, so that is unidirectional, it is a two-way communication. Okay, so and next benefits associated with the smart grid: more efficient transmission of electricity, quicker restoration of electricity after power disturbances, reduced operations and management cost for utilities, and ultimately lower power costs for consumers. You will understand what are the things actually happens, guys, in next. So reduced peak demand, which will also help lower electricity rates. And how we can reduce the peak demand by using this smart grid, because here we have continuous monitoring, right? So it is having some ICT technologies, as I told you, sensors and actuators, some different things we are using here, right? So in the existing traditional grid we are adding some different things, right? So what happens here, so how we can reduce the peak demand, we in a day, if you just take, so so at some particular time people will use electricity more. Okay, so at particular that peak time, we can also help to lower electricity rates, like the peak time the electricity rate may be more. Okay, so how you can decrease that rate, because all the things are, all the appliances and everything you are managing, so you can, according to the time, you can set the time of that things, like if you are using any dishwasher or anything, so AC or anything, you know that at what time you have the real time monitoring. So at what time the electricity consumption is more. So what is a peak time? So that time you can take it and you can monitor. And other time, in the when the demand is less, so that time we can set all the devices to work and so consume, so that you can reduce the low power consumption, right? So increased integration of large scale renewable energy systems, and next better integration of customer owner power generation system, and improved security because continuous monitoring. So using smart grid, both the consumers and energy service providers or stakeholders are benefited. Okay, so next here, benefits of smart grid. This is benefits of customers. From the customer point of view, what are the benefits he can get? For consumers, the benefit of using smart grid are as follows. Here if you see, updated information on their energy usage in real time, as I told you before, enabling electric cars, smart appliances, and smart devices to be charged. And next, smart devices to run during of peak hours to lower energy bills. I told you, like when we are consuming more energy at the peak demands, okay, peak demand of electricity, that time if we consume more electricity, we get the higher energy bills. Okay, so we can reduce it. And so we can program the smart devices to run during of peak hours. Okay, off peak hours we can make them to run. Next, different pricing options. Okay, next uh, next word we have, like I told you, like just one more thing I want to give clarity. Different pricing options, I told you, right? What is this different pricing options? This is like little bit confusion maybe for you. Like it is like, here we have a chance, like if you are going with the smart grid, different pricing like 1 week wise, month wise, there is a chance of knowing electricity, like how much we consumed, what is the rate for it. So you will get different pricing options here. So next, benefits to stakeholders. For stakeholders, the benefit of using smart grid. are as follows, like increase grid reliability, reduce the frequency of blackouts and brownouts. Okay, so here reduce the frequency of power blackouts and brownouts. This is a common words which are used in the electricity. So what is this blackout means? The blackout and the brownouts. So reduce the frequency of the power blackouts and the brownouts in the sense, blackout means the power consumption is no longer possible. Okay, so blackout in the sense, the power consumption is no more possible because of transformer failure or some different substation failure. So we can say, okay, next, power is completely out of for longer durations of time. That is the power blackout. Okay, you can say the term blackout, power blackout. Okay, so power brownout is for few hours. Okay, this is for few hours. What happens here, there is going to be reduced level of voltage. Okay, as you can observe these things, right? So like reduced power of when the reduced, so we often like we experience that at certain times of the day, if you are using the bulbs. Okay, if you are using the bulbs that are glowing at a lower strength, you may observe sometimes the bulbs, when you off the bulb or anything, so sometimes the bulbs are glowing at lower strength. That is because overall electricity load in the grid is lower. Okay, electricity load is lower at the grid, so that is the reason we are facing that. Okay, so that we can say brownout. Okay, so that is the brownout, and the blackout is completely out of the power completely cut off for longer duration of time. So next thing, properties of smart grid: consumer participation, and we have real-time pricing, distributed generation, the consumer participation, real-time monitoring of consumption, and control of smart appliances, and next, building automation, and distributed generation, integration of renewable energy resources, integration of microgrid. So these all things, and the properties of smart grid, here some other things are there: power system efficiency, power monitoring, and asset management. So that's all things are possible with this. And next, power quality, self-healing, frequency monitoring, and next, load forecasting, and next, anticipation of disturbances. So next, if you see this is the architecture, smart grid architecture. If you see the diagram, what are the things you are understanding? Just observe the things. I want to explain about this. So we here, what we have here, power generation we have, right? So if you see the terms here, we have power generation, and it this is the source of, this is a source of generation, like this is the source, these are the sources, so it is generating the power from these are the different sources. Okay, so and from the source of power generation, which can be from the renewable as well as from the non-renewable, right? So it can be anything, like if you see it is a wind. Okay, some and the solar, and next we have coal, and next we have water. So these two things comes under non-renewable, and these things comes under the renewable, right? So this energy through the different transmission lines and the distributed systems. So here what is happening, this energy, I am just saying that this energy, whatever it is generated from here, that is, here you see the diagram in this, you're seeing the dotted line here, right? So whatever it is generated, that energy through the different transmission lines, here it is different through the transmission lines, and the here again what is happening here, the different power transmission and distribution systems are there. So from there, this energy is feed to different offices and the homes. Okay, so this energy is passing to the different power transmission and distribution things, and the energy is going to be distributed to the homes, offices, and different things, right? We see that. And next, what are the things we have? We have some different meter data management systems here, and we have different here we have the home appliances and metering data buffer. So these all different things we are using here. So we see that, but one by one. Okay, in the next diagram, again we have this diagram. In that diagram, I'm going to explain. So just you see what actually happens and what are the things are existing for this. So these are all things we're going to talk. Again, I have this slide in the next concept. Okay, so in the next upcoming slides, again I have this. So there we're gonna I'm gonna explain about this. Okay, so here, if you see in this, what is happening, I just want to tell you just a brief idea. I just want to give about this. So, and this forms something known as a neighborhood network. Here we are seeing some things like a neighborhood network and different things we are seeing. Neighborhood area networks. So with the help of neighborhood area networks, the things are going to be shared. Okay, so and each of these homes have different appliances. Again, coming to here, each of this home is having different appliances, smart appliances, including some smart meter. We can see this here. The home is containing this home diagrams differently you're seeing here, right? Separate you're seeing. So that is it. It may contain smart appliances and home appliances you're seeing, right? And it is having some smart meter and but not the traditional one. Okay, don't think about that. It's a smart meter, it's a kind of meter. This can be, it can be programmable. Okay, this is more like a traditional flow of energy what you are seeing here before. Okay, but alongside we also have that connectivity to different networks. Okay, but here in this smart grid we have different neighbor area network. Some different things are coming here, and again we are connecting to the home area network here in the smart grid. In the traditional one, these things are not there. Okay, so we are connecting, and we are using the smart meter. Okay, next here we are using the different networks, and we have the sensors and different actuators here. Okay, so being different things are being used in the source, in the power generation sources, and the IP networks can be connected. Here the IP networks we are seeing, right? These IP networks can be connected to MDMs. Okay, and the meter here we are seeing, right? MDMs and the meter data buffering, and so this is the MDMs in the sense meter data management system. These MDM can be connected by wireless area networks. Okay, these are things can be connected to the wide area networks. Okay, so these are connected through this. And next, what is happening here, we have the data aggregator next, right? So this data aggregator unit we have, so which is sort of like from each of these homes, this information can be aggregated by using this data aggregator. Like, it is going to take the data completely, so it is going to store the data in the cloud. Okay, that's how this data aggregator unit helps to store the data. So, and this unit has a metering data buffer. This unit is having the metering data buffer, which basically stores and buffers the data. Next, so we have what we have actually. We have some different variation between the traditional and the information conceptual flow energy, right? So here we have, this is the traditional grid, which I told you, just power is coming through different substations. But here, coming to the smart grid, what is happening, these all the things are existing. With the traditional one, these all things are not there. But here, we not only the power supply, we are adding the different technologies here. So here we are using neighborhood area, and we are using it the home place in a home area network, and we are having the smart meter and the meter data management systems and the IP networks. We are using the different things here. So this is how it is making the traditional one to smart grid different. Okay, and next, if we see here, the smart grid domains, here we are seeing the conceptual model of the smart grid. We have different components over here. We have the customers, service providers, operators, some different things, operations, and the markets, and the transmission and the generation system. So different things we have, right? So it is showing what it is actually showing. It is showing this different flow of energy. So these are blue lines you are seeing, and there's some dotted lines you are seeing, right? So in this diagram also you can see, this is the yellow, in the yellow color it is showing some dotted lines, right? These are the electricity flows. These are describing the electricity flows. And next thing, a different flow of energy as well as the communication flows. These are the blue one, which we are seeing the communication flows. The dotted lines are here, right? So those are showing the electricity flows between the customer, so between these between the customer, yeah, between the customer service provider, so and the distribution system, transmission system, and the generation system, right? So here, blue colored one are basically showing, or I can say depicting the flow of communication, and it's a secure flow of communication in the case of smart grid. Okay, so this is just a conceptual model how the flow of energy can be done. So we see some of the components of smart grid. So these are the components of smart grid. Okay, different components. We have smart home, renewable energy, consumer engagement, and next we have here. Next thing is the operation center. This is the operation center. Okay, so because of I think you may be seeing here. Next thing here, distribution intelligence, and next plug-in electric vehicle. So these are the components of smart grid. So we go with the smart homes. Smart home, it uses the emerging smart grid technologies to save energy, seek out the lowest rates, and contributes to the smooth and efficient functioning of our electrical grid. And next, the interactive relationship between the grid operates utilities and consumer helps in proper functioning of smart grid technologies. Computerized controls in smart homes helps to minimize energy usage different times. Okay, like when the power is under stress or from high demand, and next means load is more. Okay, or even to shift some of their power used to different times when the power available is at lower cost. So different things, peak hours or to off peak hours. So next, in the smart home, what is happening, it depends on the smart meters. In this smart grid, what is happening, these houses are depends on the smart meters and home energy management systems. Home energy management in the system, systems in the sense on the rooftops. Here in this diagram, you can see on the rooftops, the solar panels can additionally generate some electricity to supplement the electricity that is supplied to the home. Okay, the smart home, again, it has a smart appliances and home power generation. Okay, so next thing, we have smart meters. Smart meters at the home. So those things provide a smart grid interface between the consumer and the energy service provider, operate digitally, allow for automated and complex transfer of information between the consumer and the energy service provider, helps to reduce the energy cost of the consumer, and usage of electricity information also it provides. And next, we have home energy management systems in the smart home, right? So allows the consumers to track energy usage in detail to better save energy, and allows consumer to monitor real-time information, allows to create settings to automatically use power, and next to avoid peak demand rates, helps to balance, and next balance the energy load in different area, prevents the blackouts. So next thing, we have smart appliances at smart home. So automated and robust in nature, response to signals from the energy service provider to avoid using energy during times of peak demand, include consumer controls to override the automated controls. Next thing, we have home power generation. So these are the terms which I'm discussing at the particular component smart home. Okay, in this smart grid concepts, these all things comes. So home power generation system at consumers end, rooftop solar electric system, small wind turbines, and small hydropower systems we have in the home power generation. These all things can be used. Okay, home fuel cell systems produce heat and power from the natural gases. Surplus energy generated by the home power generation systems can be fed back into the grid. And in case of islanding, like a home can have power from distributed resources and home power generation systems. So we have renewable energy. This is a definition for renewable energy. Okay, so according to the International Energy Agency, so this is renewable energy. We don't need to go much about it, but we see what is this. Renewable energy is derived from natural processes that are replenished. Because we have the basic knowledge what actually renewable, right? But we see, so I don't know, I'm making you bore or what, I don't know. Anyhow, we are end of the class, right? So we see the things in tomorrow, but just we discuss about these two topics, like these two slides we discuss. So in this world, according to the international agency, renewable energy is derived from the natural processes that are replenished constantly in its various forms. It derives directly from the sun or from heat generated deep within the earth. Included in the definition is electricity and the heat generated from solar, wind, ocean, hydropower, biomass, geothermal gas resources, and biofuels, and hydrogen derived from the renewable resources. So this is the definition for that. It reduces the environmental pollution. And next, the consumers capable of generating energy from renewable energy sources or less dependent on the microgrid or main grid. And next, in addition to that, they can supply surplus amount of energy from the renewable resources and make profit out of it. And consumer engagement, here consumers can save energy with the proper scheduling of smart home appliances, pay less for consuming energy in off-peak hours. When peak hours, if you are consuming more energy, we get more electricity bill. So when we are using the electricity at the off-peak hours, okay, that time if we are using the electricity, so we get less power bills. Next, energy service provider gives incentives based on the energy consumption of the consumer, and they can save the money. And next, consumers involvement in the following ways, like time of use pricing, net metering. So these all things. Next, we have consumer engagement. In the consumer engagement, in time of we were talking about these things, right? In time of use pricing, the consumers are encouraged to use energy in off peak hours when the energy load is less. Throughout the day, the energy load on the grids are dynamic, and in on peak hours, if the requested amount of energy is higher, it leads to less efficient energy distribution, more pollution. It depends on the non-renewable energy resource to meet the peak requirement. Okay, so and the home energy management systems try to schedule the smart appliances in off-peak hours to ensure the efficient service. And net metering, it is feasible with the installation of smart meters. So this is these things we discuss tomorrow. So I'll take that image for now. Okay. So. Roll number 50, I got your attendance. And next, 501.
Present, ma'am.
503. Okay, 505.
Present, ma'am.
And 509.
Present.
Yes,
Present, ma'am.
Yeah, I got yours. 512.
Yes, ma'am.
520.
Present, ma'am.
523.
Yes, ma'am.
528.
Present, ma'am.
535. 540. 43.
Present, ma'am. 40.
Yes.
40.
40.
Present, ma'am.
Yes, I got your attendance. 43 is present. 44 is present.
Yes, ma'am.
Yeah. 46. 48.
Present, ma'am. 548.
Yeah, I got yours. Next, yeah, 540.